All right, well, welcome back, folks. I apologize about yesterday again. So hopefully you had a chance to watch the video. If not, please make sure you watch that video this afternoon or try to get it done. Um, but you'll need to have watched that video in order to make sense of what we'll be doing here moving forward. And so please make sure you watch that before this afternoon. And then what I'll do is I'll also make this video due tonight. Okay, and that way then if you haven't had a chance to watch that video yet, yesterday's video, you can go ahead and watch that video first, and then go ahead and watch this video, and then get the work done here. Okay. So what? Just as a quick review of what we talked about yesterday. First of all, I wanted to include this primer on conversions, and I admit and I know that this primer is this is a very quick over and very general overview of conversions. Some of you will already have done this, and so this is all redundant and it's repetitive. So please bear with me with us on this one, because I do need to teach this one, because some of us don't have this. I haven't had this yet, and I know it's for those folks that this won't. We're not spending enough time on this for you to do it well. And so, it's kind of a balancing act that I need to do to make sure then that those of you who have had it don't get bogged down by this discussion too much, because I do want to go on and talk about the kinematics. But then also those of you who haven't had it, that it doesn't overwhelm you with this whole brand new topic here of conversions. Okay? And so this is the compromise that I drew, and I think that it's hopefully a good compromise. I've posted these notes for you. These are these slides are an add-on. They are an add-on to the lecture notes that I've already given you. So I've posted those for you. Make sure you take a look at it. And so because then that this is a compromise, okay, it may not be complete enough for those of you who haven't had it before. So what I would suggest you do is come by and see me, and we'll practice going over these conversion problems, and we'll work them out together. And then through that repetition, of doing these conversions, you'll be able to get that, and then you'll be well prepared for what you will see later on, either in chemistry classes or your physics classes, and you do some of these conversions in your bio classes as well. Okay, so like I said, do your best with it, and come by and see me if you need extra help with this. Okay? But basically, the idea behind conversions, folks, is that we want to be able to change the way that a particular measurement looks, because we need it for some other reason. Okay, we need it for other reasons. So there are many occasions where we need to do these conversions in order to obtain a measurement that we can use in order to continue on. So for example, just as a quick example, here in the United States, we have, with our tools, we have two different units that we use, measurement units that we use for our tools. We have the standard, or the empirical system here. You go out to the tool shop, to Lowe's or to Harbor Freight, you can see that they sell two types of tools, and that is tools that are that have been made and measured out in the metric unit. The tools, you'll see them in millimeters, you'll see them in meters. Okay, and then you have those tools that have been measured out in the standard and empirical system, which is going to be feet and inches. And so, if you have a bolt that requires a metric ratchet, okay, then and you only have a ratchet in the empirical system. Now I wouldn't suggest you do that, because the fit isn't always right either. So I wouldn't suggest you go ahead and use a standard ratchet on a metric bolt. You're gonna strip that bolt. But let's say that's all you have. You want to find then the standard ratchet, the standard ratchet that's going to come closest to that metric bolt, and you can try using it then. Okay? And if that's the case, then you have to do the conversion. You have to do conversion. A lot of us don't do the conversion. What's the standard way that we typically do it? We just start fitting ratchets into and see whichever one fits the best. Okay, but that's not probably the best approach, but it's the simplest one. So that's an example of a real world need to do the conversion. Okay, so we do have to do these conversions, and these conversions help us. And so these conversions that we do are not simply limited to what we do here in class or science, but we carry out if we can do these skills, we can carry these skills out into the real world as well. Furthermore, I pointed out to you yesterday in our lecture that if you learn how to do these conversions here, a lot of the algebra word problems can end up being very simple if you if you're able to do these conversions. If you can identify and work it out in the way I'm going to show you in just a moment, you can do a lot of the algebra word problems as well as a conversion type problem. Okay? And so conversions are not just limited to converting measurements. You can use the method of that I'm going to teach in just a moment to work out algebra word problems as well. And so the skill here that you learn, is going to be very important. It'll be very useful. But conversions is a one part of a larger topic known as dimensional analysis, and I teach that in my classes later on. So if I see you later on, we'll learn about that. And so dimensional analysis is an absolutely powerful tool that I think we all should eventually learn how to use. Okay? But with these conversions, then what we're doing is, in order to make these changes, in order to convert one measurement into an equivalent measurement, so make sure you keep this in mind, that the two measurements that you get, the one that you start out with, the measurement you start out with, and the measurement that you get at the end of the conversion process, they're the same. They are the same. They look different, but they refer to the same quantity. They refer to the same distance. They refer to the same mass. They refer to the same time, the same speed. We're not changing what we are measuring. We're not changing we're not changing what is being measured. We're just changing how we describe that particular property. Okay. So as a result, then, because they are equivalent measurements, we need to have equivalent relationships. That is, we need to be able to define then the relationship between two different types of measurements. Okay? And so that's what we refer to as these conversion factors. Okay? And so these conversion factors then are based upon these equivalent measurements. And these equivalent measurements, like I pointed out yesterday, are completely arbitrary. Completely arbitrary. Like I said, nature does not recognize these these measured values that we have assigned to certain properties. Okay? 60 seconds comprising 1 minute. Time doesn't recognize, nature doesn't recognize time in that manner, right? Nature and the universe recognizes the progression of time, but it doesn't measure out the units of time. That's something that is a human construct. We have come up with these units of measurements. We have arbitrarily defined then these particular periods as a particular period of time. And so at that point, then we have related these particular units of time to one another. So for example, we have said then that a 60-second block, whatever this unit of seconds are, 60 of those seconds, 60 of those units of time is going to be equal to 1 unit of time that we refer to as a minute. So that's an arbitrary assignment. And in much the same way, in any of these assignments that we've given, any of these relationships here, these are arbitrary. And nature doesn't recognize them. As such, then, we have agreed to them. And because of that agreement, we can use this then to do the conversions that we need. Okay, so make sure you keep that in mind as we move forward. Okay? All right. And so with that said, then, there are units of measurement. Okay, there are ways that we can describe how we the measured quantities. And so there are a couple of different systems out there that are most commonly used now. We have the standard empirical system that is really only used now in the United States predominantly, and even England, folks, even in the United Kingdom, where the English system started, the standard system started, the empirical system started. They don't even use it anymore. They use the metric system. Okay? And so we are the only country, for the most part, that still ends up using the standard system there. But in science, we don't. Okay? We use a unit of unit known as the metric system. We use the metric system here. And in science specifically, we use what's called the SI system of measurements, which employs metric units. Okay? So if you take a look at this here, we have the units of measurement on the right-hand side here, and what they are referred to. Okay, so let's go ahead and let's take a look at this really quickly. All right. So if you see the unit kilogram here, okay, the unit kilogram then always refers to a mass. Okay, it describes a particular mass. Okay, and so if we want to find out how large or how small that mass is, we assign a number to it. And so remember, all measurements have two parts to them: a number, a numerical portion, and a unit portion. The unit portion, it describes the physical quantity that is actually being measured. Okay, length then and the kilogram then is based off of the metric unit of gram. Okay? And so, like I said, the SI system is a slight modification of the metric unit, the metric system, in that we use slightly different units. Okay, so the base unit for the metric mass unit is going to be the grams. Okay? Length then is going to be meters, and we see that here. So whenever you see the unit meter here, then it's going to be referring to the length. Okay? And again, if we want to measure it out, we assign a number to it to determine how big or how small this particular length is. Okay? The temperature unit is Kelvin. Okay, the temperature unit is Kelvin. You'll also see then degrees Celsius. That's going to be the metric unit of temperature. The SI unit for temperature is going to be Kelvin. You'll learn in chemistry the difference between those two. Okay, we're going to skip the amount of substance here. Yeah, that you won't need. Time you'll need. Okay, because we talked about measuring time. We need to know time to measure speed, for example. Okay, and the unit for time then is going to be seconds. Okay? And that's both the metric and the SI unit. Okay, so you have to be aware of four different units that we use: the mass, the length, the temperature, and the time unit. Okay, the other ones you don't have to worry about, but that's what we have to be able to use moving forward. Okay? All right, so let's go ahead then, and how do we relate differences in sizes? Okay? Now, the metric system is very convenient. It's very convenient because it relates the differences in sizes now of a particular measurement using factors of 10, just simply factors of 10. So let me just let me give you an example. Okay? So we know then that there are 12 inches in 1 foot. Okay? We know then that there are how many? 3 feet? I don't even know. But what we have then here are two equivalent measurements. Okay. Okay. I'm sorry. I was just trying to recall then, and this is why I hate the empirical system. I'm drawing a blank here. But you realize then that there's what is it, 3 feet in a yard or 3 yard, whatever it is. Okay. But then there's let me find that. That's bothering me. Let me find the conversion here really quickly, because I want to point out something. I want to draw a comparison here for you. Okay. Sorry, hold on 1 second, guys. Sorry. Yeah. So that's why I hate the empirical system, folks. And so we have then 3 feet in 1 yard. Again, that's what I get for getting old. I forget all these things. All right. So the point here then is that these two represent equal length. When you talk about 12 inches, you're referring to 1 foot as well. When you're talking about 1 yard, you're referring to 3 feet as well. 1 and 12, 1 and 3, that's not an easy number to remember. Those aren't easy numbers. They are fairly easy numbers to remember, but obviously as you get older like me, I couldn't remember that second one. But those are not as easy as the metric system here. Okay? Because if you take a look at what the conversion here then, and let's take a look at this, we had the gram. Okay, and I'll point this out. Okay, and so we have the kilo. Let me do this. Let's stick with length units here. So we're dealing with meters. Let's stick with meters. Okay, so we have then the kilometer or the kilometer. Okay, and the meter. Okay, and how do we express the same length here? So we have 1 kilometer, 1 kilometer for every 1,000 meters. Okay, so we have that. Okay, we also have then, for example, let's do centi. I'm sorry, 1 meter here. Let me go ahead and do this here. 1 meter. Okay, and that's going to be equal to 100 centimeters. meters, okay? And so what you'll notice here then is based upon this base unit here. The base unit here is meters, and so we'll always have a base unit we compare every other length to. We can define other lengths, okay? So we have then a kilometer, which is roughly about 3 city blocks, 3 city blocks, depending on what city you live in, okay? And so you have then 1,000 meters, and it's going to be equal to a 1 kilometer, okay? And so for 1 meter, then you have 100 centimeters. And so the lengths here are equivalent. But if you notice, then each length is going to be related to by some factor of 10. And so that said, then the conversions here end up being simple because either you're going to multiply or divide by some factor or factors of 10. And that's why then this becomes very simple. What you have to make sure you recall then are the different prefixes here, okay? And the ones that I highlight here for you are the ones that you'll probably come across and see the most. Okay, you'll have to basically remember them. Okay, so whenever you have a kilo in front of a base unit, that means then whatever you have then is 1,000 times larger, 1,000 times larger than the base unit. So you have to multiply by 10, by 10, by 10. So 10 to the third is going to be 1,000. Get from the kilo to the base unit here, you have to multiply by 10, multiply by 10, multiply by 10. You're multiplying by 10 3 times, so therefore it's going to be 10 to the third. Okay, and so multiplying here, okay, going from base unit here to the centi here, you're going to go ahead and multiply by 10, multiply by 10. I'm sorry, go the other way. Sorry, going the other way. Back. Going the other way. We're going to multiply by 10. Going this way is then we will have to from centi, sorry, okay, centi to milli to back to the base unit. We will have to multiply by 100. Okay. All right. So with that said, then the conversions here are pretty straightforward. Okay, they are pretty straightforward. I'm sorry, going the other way around. Let's see, that's what I get for this here. Let me go ahead and do this around again. Okay. So multiplied by 1,000, multiplied by 100. Okay. So the conversions end up being very simple. You can change from one unit to another as long as you know what these prefixes are. And like I said, I want you to make sure then that you can remember these 3 here because they'll come up quite a bit. Okay. All right, let's go ahead then. And I think for the most part, it's practicing these here that's going to help you. Okay, so make sure you have that in front of you. Okay, but when you do these conversions, typically, folks, the method that you use, you should have a fairly systematic and methodical way that you go about solving for these problems. And we're going to work through these here. But basically, when you do these conversions, there are 3 basic questions that you're going to ask yourself. Okay, 3 basic questions you ask yourself. Okay, and that is, what do you start out with? What's the measurement that you need that's given to you? Okay, what you start out with? What unit, what measurement do you want to end up with? Okay, and so basically here we're going to look at the units of measurement here, and then finally, what conversion factors do we need? And these conversion factors will be those equivalent amounts that we talked about in 2 or 3 slides back. Okay, so we want to make sure we define what those equivalent amounts are, and then we plug them in as a conversion factor, as a ratio, as a fraction, and the way we plug it in will be based upon what we need to cancel and what we don't, and what we want to keep. And so, like I said, all this right now doesn't really quite make sense, but when we start working out these problems here, I think it becomes much more straightforward for you. Okay, so let's go ahead, let's work out a problem together. Okay, all right, so let's take a look at this problem here. Let's take a look at this problem here, and let's identify first of all what is given to us. Okay, and identify what we are asked to solve for. Okay, so how many seconds are in a workday that lasts exactly 8 hours? Okay. So what they're telling you is that this is the measured, this is what they start out with. They measured this amount of time. So this is given. This is the given measurement here. So this is the given measurement. So we were asked about an 8-hour time interval. And so the question then is, how many seconds are in that 8-hour time interval? So this is what they want you to solve for. So this is what we want to end up with. This is the quantity that we want to end up with, and that's what we want to solve for. Okay, so we are basically solving and converting to this. Okay, all right. So the question then is there a relationship between hours and seconds? do we know what the relationship between hours and seconds are? Now, some of us do, okay, but many of us maybe still know. And so we do know this, though. We do know this, and we all know this. We know that there are 60 minutes in 1 hour. We know that. We also know then that there are 60 seconds exactly equal to 1 minute. Okay, so we'll take advantage of both of those equalities. We'll take advantage of both of those equalities here to get this conversion done. Okay, and so we've answered the 3 questions here, folks. We've answered the 3 questions. At question number 1, what is given? Question number 2, what are we solving for? And then question number 3, what conversion factors do we need? Okay, so there are the 3 questions. And so now let's set up the problem. Let's go ahead and set up the problem. And this is what I would suggest you do. Okay, all right. So always start out and write down what you're given. So we were given here, and I'll try to finish up here, folks. We'll start out with this. This is what we were given. Okay, and we're going to do this as a fraction. Okay, so this is one long fractional calculation. We're going to plug in fraction, and we're going to multiply fractions. That's essentially what we're going to do. Okay, and so this is our first fraction here, and hopefully you can recognize that whenever you have a whole number, the fraction the whole number over 1. Okay? And so we want to end up with, and I draw an arrow here to indicate the direction of our conversion here. We want to end up with units of seconds. Okay? We want to end up with units of seconds. Okay? All right, so the question then is, these two are not the same, but can we get from, so right now, don't worry about the number, can we get from hours to seconds? Okay? And the answer is yes. Okay? So let's imagine then we plug in a fraction right here. Okay? This unit hours, and I'm going to write this right now as a fraction over 1. This unit of this fraction has hours in the numerator. Okay? So if you can imagine, if we take this first equality here, okay, and we plug it in here as 60 minutes, okay, and 1 hour. If we plug it in that way, with minutes on top, hours in the denominator, minutes in the numerator, hours in the denominator, do you see then that the unit hour here cancels out? It does. It cancels out because whenever there's two factors or 2 variables, 2 numbers are the same, when we say they cancel, they give you 1. Okay, so hours divided by hours is going to give you 1. And so basically, we have taken care of this unit here, and we have now minutes on the top. Okay, so we've used this equality here, and we plugged it in as a ratio. Okay, as a ratio, as a fraction, with minutes on top, hours on the bottom. The reason why we do that is because we want to be able to cancel out this unit. Okay, and the goal then, and the arrow here points us in that direction. The goal then is to get to seconds. At this point, then we still don't have that. We have minutes on top here, we have seconds over here. Okay, and so what that means that we have this second conversion factor, the second fraction that we can use, and we can plug it in. And hopefully you recognize that we can plug it in the same way. If we want minutes to cancel out, we're going to put minutes on the bottom here. So we have minutes on the bottom, okay, and then we're going to put seconds on top. Seconds on the top, okay, which allows us to cancel that unit of minutes. And so now, if you notice, on both sides of the arrow, we have seconds and seconds. Why is that important? Because then we can stop right there. That means then that we're done. We don't need any more conversion factors. Okay, we can go ahead and just punch in the numbers and calculate them. Okay, so at this point, then the conversion now has the same unit on both sides of that arrow. We just need the number now. We need the number. Okay, so when we plug that in, it's going to be 80 times 60 times 60. We have then 28,800 seconds. Okay, what this number is telling us then, folks, is that that's how many seconds are exactly equal to 8 hours. And so this is the conversion that we'll be practicing some more tomorrow, and that you'll be doing, and that I basically did at the end of the kinematic problem that we did. That I went through fairly quickly, but with the wrong assumption that everyone is able to do it. So this is the idea. This is what we have to be able to do moving forward. So what we're going to do, and what I'd like you to do right now, just to finish up then, is I want you to try a problem to finish up. I want you to do this problem here. Okay? I want you, the question is asking you to express 750 decigrams in units of grams. So I want you to set up this problem the best you can. Show me how you would do this conversion. Show me what the equivalent measurement is in grams for 750 decigrams. Submit that for the work today. and then have this for tomorrow. Don't get rid of it. And we'll start out with this problem tomorrow, and then I'll work it out for you the way that I worked it out for you in the previous slide, and the way that I would like you to continue working it out moving forward, because that's a very simple and it's a very straightforward way to do conversions. Okay? And so we'll compare answers tomorrow, and then we'll continue with these conversions. And again, folks, it's just a matter of practicing these conversions. And again, we'll do quite a bit here in class, and then I'll try to post a packet for you that allow you to practice these conversions, so you can practice them as well. Okay. All right. So with that, and I'll try to post it by this afternoon. I'll try to get it done by this afternoon so you can start practicing it, and I'll sign it for tomorrow. Okay. All right, folks. Have a good day, and then like I said, if you need to stick around after lecture today, and then we'll go over these conversions together. Okay. All right. If not, I will see you folks tomorrow. Okay? Have a good day.